Right, so today we're going to be doing January 2023 mathematics, January 2023 number 3. All right, let's read the question. The following diagram shows 3 quadrilaterals. Quadrilateral just means quad is 4. It's a 4-sided shape, right? PQR on a square grid. P and R are images of P. So we have P and we have Q and R. These are the images after undergoing 2 transformations. Now, let's go through the type of transformations they bring for CSEC. There are 4 types of transformations that they bring. Right? The first transformation is a slide. And to know that it is a slide, the orientation is the same. Right? The size is the same. And the orientation of the image, that is the same. Right? Number 2, this is the first one, a slide. The second one is enlargement / dilation. And as the name suggests, the images either becomes bigger or the sizes change, right? It either becomes bigger or smaller. So if it becomes bigger, you know that, okay, the transformation it underwent is a enlargement, right? If it becomes smaller, you know it undergoes a dilation, right? The third one is rotation, right? Again, the size is the same, yes, but the orientation, that is the way the image look is either it turns, right? So the orientation is different. The last one, right, is reflection. Again, the size is the same, but the orientation of it is opposite each other. It's flipped. The orientation is flipped, I should say. Now, from these 3 things that we know, what object P and image Q, what type of transformation did P undergo to form Q? We can clearly see that it got bigger. So we can say that Q, just write this at the side, Q underwent an enlargement. Then if we look at P and R, right, we see first off the orientation changes. So it cannot be a slide, right? It cannot be enlargement or dilation because it did not get bigger. It's the same size, right? It's either a rotation or reflection. Again, it can't be a reflection because if we compare P and R was not flipped, right? It has to be flipped. This was not flipped. This actually turned. So because it has, you could see that P, R turned, right? We can say that R is a rotation. So the 2 types of rotation. So the 2 types of transformation that this underwent is P underwent an enlargement to form Q, and P underwent a rotation to form R. Yeah? So now let us look at the question. This wasn't even us doing the question. It was just us noticing what type of transformation it was. You don't need to write all of this. This is just stuff that you're supposed to know when you're doing transformation. These are the 4 types of transformation that they will test you on. All right, let's look at A. On the grid on page 8, that's just the previous page, draw the image of quadrilateral P after the translation by a vector 10 and minus for label P1. Right? They said translation is known as slide, right? There are 2 ways to do it, right? The first way would be, again, if we see it's 10 minus 4, the one on top, which is 10, it would be your displacement along your x-axis, and the one at the bottom, which is minus 4, would be your displacement along your y-axis, right? So let's write that. That's 10 and minus 4, right? So it displaced, 10 is displacement on your x-axis, and so is a displacement on your y-axis, right? So it's going in a positive direction and along your y-axis. I'm sorry, along your x-axis, because 10 is positive, and then negative 4 along your y-axis, it would go in a negative direction, right? So first off, we can literally just count, right? It's P. So we're going to count 10 units. That's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So this first point here is now here. Hold on, let's just make sure 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And then it's 4 units in a negative direction along your y-axis. So it's going down. 1, 2, 3, 4. So you see that that top point is here. Now, instead of doing the other points, you can just look at how large the other points are from this point. If you look, this point here is actually 1 unit. So it would be here, here, and here. Because we can do this because we know that for transformation, the size is the same. So it do not increase in size, and the orientation is the same. So it's not the different orientation, right? Or you could just do the same thing that I just now did. 10 units across, that's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And 4 units down, 1, 2, 3, 4. So we got that there. You do the same thing for here. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And 4 units down, 1, 2, 3, 4. Right, and then the same thing for the last one, 10 across, 4 minus 4, which is 4 units down, right? So you know, hey, this here, once I do that for all my points, this here is the first image for your transformation. Let me just draw it. Right. And the last one. Now, again, like previous years, there is other ways to do part 1, right? The other way would be to get, what you call this thing? The coordinates for each point here. So this first point here is minus 7. X is minus 7. Y is 7. Right? This one here is X is minus 6. Y is 6. Sorry. Yeah, Y is 6. This one here, X is minus 7. Y is 4. And this one here, X is minus 8 and Y is 6. You can get the coordinates of each of them, turn it to a column vector, and add that translation vector. All right, so just zoom out so I can remember, see it. It is minus 7, 7, minus 6, 6, minus 7, 4. And then what's the next last one? Minus 8, 6. Zoom in, 8, 6. All right. Minus 8, 6. All right, these are the coordinates here. And then what you would do is change these into column vector, column matrices, where x values on top, y values at the bottom, minus 6, 6, minus 7, 4, and minus 8, 6. All right? And then, again, this is equal to this. You would add your translation. What is your translation? You're going to add 10 minus 4, 10 minus 4, 10 minus 4, and then 10 minus 4. You're adding it, right? Once you add these, you're going to get your image. All right, so minus 7 plus 10 is 3, 4, 7 plus 4 is 3. Yeah, 3. So the coordinate for this image would be 3, 3. Right, the next one is minus 6 plus 10, that's 4. Then 6 minus 4 is 2, so the next coordinate is 4, 2. Right, this one is minus 7 plus 10 is 3. 4 minus 4 is 0, so the next coordinate is 3, 0. Right? And this last one, minus 10, is 2. And 6 plus minus 4 is also 2. So the coordinates for this would be 2, 2. Right? And when you plot each of these points, you're going to get this, what we have here, what we already drew. You see, this is 2 and this is 2. This is 3 and 3. This is 4 and 2. So let's see. 4 and 2, 3 and 3, 2 and 2. And then this last coordinate here is 3, and your x, along your x-axis, y is equals to 0. So this coordinate here is 3, 0. So we can see this way we can also do part 1. Right? Part 2 says the reflection in the line y is equals to 0 and label this P2. So this is P1 and we want P2. Now they told you that your mirror line is along the axis where y is equals to 0. And I told you that y is equals to 0 along your x-axis. So your mirror line will be right here. Let's make that green so we can see it. Right? So that green line there is my mirror line. And when we're doing reflection, we just count the distance from your mirror line to your object, and you do the same thing on the next side for your image. So this coordinate here is 1, 2, 3, 4. So you're going to count 4 units away. 1, 2, 3, 4. So it's going to be here. The same thing we're going to do here. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6 is going to be here. Right, this one is 7 units away, so you're going to count 7 units, so it's going to be here. Now the last one, this one is 6 units away from your mirror line, so you're going to count 6 units away from your mirror line, that's here. Right? This would be P11. So again, for mirror line, for reflection, the hardest thing for reflection is just to find out where my mirror line is at. And they give you that. So once you find that, let me just make this here. Right. Right, so this would be image P. Right, and that's how you would get the answer for that. Now, they said describe fully a single transformation that maps quadrilateral P onto quadrilateral Q. We already found out what translation is that as enlargement, right? And then the next one was for quadrilateral P to quadrilateral R. That is rotation. Now, when they tell you to describe it, to describe these things, there are certain things that we need to remember, to put in. So for enlargement, and you need to remember this, right? For enlargement, you need the scale factor. Your scale factor is your image over your object. So you could choose any length of your image and divide by object and you'll get your scale factor, which is also known as K. Right? The next thing you need to know for enlargement is your center of enlargement. And I'll teach you how to do that. Your center of enlargement. And I think that's it. So for enlargement, there are two things that you need to find: your scale factor and your center of enlargement, which are things that I will teach you how to do. Let's just make this, shift this around. Right? So first off, let's find out our scale factor. Now, scale factor, again, is your image over your object. So let's get your image as Q. We can say this is the length from the top point to the bottom point is 1, 2, 3, 4, 5, 6, 7, 8, 9. So the length of the Q is 9 and the length of P is same from the top point to the bottom point is 1, 2, 3. So this is actually going to be 9 divided by 3. So my scale factor, or K, is going to be 9 divided by 3, which is equals to 3. So my scale factor is 3. My center of enlargement, now, this is something that you need to remember, is where you're going to take these points and you're going to connect them. Right? And where they intersect, all of them intersect when you connect the object and the image. The points for them, right? Let's say this one. Right, so this one, hold on. This one here, going along the line there. Right? Let's go with the right, this one is this one here. You're connecting this coordinate with the corresponding coordinate. So this line here corresponding with the image. Right? And then you're going to take this. Again, you guys, you have your ruler on you, so it's easier to do, right? This line here, and you're going to go through that. So you see where they all intersect at. They intersect at this point right here. So again, let me explain what you're doing. You are joining images and object, the corresponding points, and where all four of the corresponding points intersect, or where more than 3 intersect, right? That is your center of enlargement. My center of enlargement, my x value is -10. My y value is 7. So my center of enlargement is going to be, let me do this in a different color so you would not get confused. This will be -10, 7. Right? And that would be my center of enlargement. Again, I wouldn't put it here. I'll just erase this. Now you don't have to put exactly how I put it, right? You just need to make sure you mention these three things, right? Your scale factor was, again, that was 9 divided by 3, which is 3. And then this one, your center of enlargement, is where all of them intersect, right? Is minus 10, 7. So your answer here, I will write down because writing is going to be a little bit hectic, right? What you're going to put is quad, no, you don't put quad, right? You gotta put quadrilateral. Quad E underwent a transformation. Transformation of enlargement. So first it's saying what type of transformation is done to create quad Q, quad meaning quadrilateral Q, right? With a CELE factor, or you can put P, which is scale factor, of 3 and a center of enlargement of minus 10, 7, right? And that is all you need to put something along these lines, right? You don't need to put exactly what I put, right? But you need to mention what type of transformation it is, and from the type of transformation, you know it is, you have to mention the scale factor and the center of enlargement, right? Now, quadrilateral R, right? We said that quadrilateral R underwent a transformation of rotation. Now, again, we know quadrilateral R underwent a transformation of rotation. Now, when it is a rotation, there are a few things that you need to remember. For rotation, right? You need to know the center of rotation. I'll teach you how to get that. The center of rotation. Number 2, the direction. Direction of rotation. That means if it went clockwise or anti-clockwise, right? That is, if it is clockwise or anti-clockwise, depending on how you'll know clockwise and anti-clockwise. So again, center of rotation, the direction of rotation. The next thing is the degrees that the object rotated. Now, to do this, you need a compass, right? So let's go ahead and try to. So the first thing we're going to do is we're going to find that center of rotation. Now, to find that center of rotation, it's a few steps process. The first thing you're going to do is you're going to connect. Going to connect corresponding points. So the corresponding points for this, right? I'll make it into a different color so you can recognize. Pink, right? So we see the corresponding points for your object and your image. We're talking about from object P to image R, so those are your corresponding points, right? Now, when you use a ruler, this is going to be easier for you, right? It's a little bit difficult for me to do this here, but what you're going to do is when you measure the length from one corresponding point to the next, you're going to find the middle of it. So let's just say this was 6 centimeters. The half of 6 is 3. So you're going to put your little dot at 3. Let us Now please note, because I'm doing it on the computer, it's going to be a little bit weird, right? So my center here, I'm going to use pink again, is somewhere along right here. All right? And then next one, you're going to do the same thing. You're going to draw two corresponding lines, right? So we're going to draw from here to here. I'm going to use a different color so you could recognize what I'm doing. Right? I'm going to use yellow. Right? The same process, you're going to find the middle of these 2 points, which is somewhere around here. Use again, I'm going to use the corresponding color. Somewhere around here is the middle. Right, again, if you have this page in front of you, using a ruler and stuff, it will be very easy for you. So you find the middle of these two corresponding lines, right? Oh, yes. The third step, so that's the first step, draw two corresponding lines. Then you find the middle of the corresponding lines. Your third step is to draw a degree or angle, right? Right, so you're going to use, again, this was my tool, my compass. Right, let's make this a little bit smaller so you guys could see. And you're going to put that cross little section there on my dot, the center. Right? So let me just see if I can do this really quick. Alright, so you're going to draw it here. Just line it up with that line, and you're going to put the cross by where my dot is. And you're going to draw a line for 90 degrees. Right, let's draw a line. So in 90 degrees, you can see that this is 0, right, and 90 degrees is here. So you're going to draw a 90 degrees that is going through that line. You're going to just draw it straight. But yeah, right? Let me just use pink because that's the color. And you're going to do the same thing for the yellow line that I did. Right, the yellow line that I did just now. Right? Line up my line. Oh. Right. Right. And then you're going to draw a line through. It's going to be somewhere along these lines here. I'm going to draw that into yellow as a yellow line that you can see. So if we, oh my God, you notice, right, I have my two 90 degrees angles. So this 90 degrees side. So you see that's the second line here, it forms a 90 degrees, and this yellow line also forms a 90 degrees with my corresponding lines. Right? And where they intersect, in this case, they intersected at -4, 2. This here is my center of rotation. Let me put this in black. Right? This right here, where they intersect the 90 degrees angle, is my center of rotation, which is -4, 2. So that, again, that is the first thing that we're going to be doing. Right? What is the center of rotation? We just now showed how to find the center of rotation. It's -4, 2. Right? The next way is we're going to look at the direction. Sorry, no, the degrees. So, to find the degrees, we're going to draw two other corresponding lines. So I'm going to draw two other corresponding lines. But you're not joining them up, you're going to that center of rotation. So we're going to draw that line to here. Let's put that as blue, because I didn't use blue. That line to here, and then you're going to draw the next line. And you're going to connect the corresponding point of that first line there to the 90 degrees. Not to the 90 degrees, to the center of rotation. Right? So this point here, let me put it in blue so you can see. This point here corresponds with this point here. Right? So you're going to draw those two and connect it by the center of rotation. Then you are going to use your protractor and you're going to line up that long line. Just line it up. Alright. Where they intersect would be where that T on the protractor is. Let me just. Right, so this is 0. And if you look at where the next blue line is, let me just rotate it a little bit so you guys can see. Right. You can see that, listen, how many degrees is that it rotates? 90 degrees. So what is the angle it rotated at? 90 degrees. Right? And then the next one, the direction. If we look at this, let's remove our protractor now. And it is going from this line here, which is P, to this line here. Right? It is going in an anti-clockwise direction. So what direction did it go into? But after you find out the degrees, it is clear to see that it went in an anti-clockwise direction. Right? So now that we have this, let's write out what you're going to see. You're going to say, again, quad P or quadrilateral P underwent a rotation to produce, or create quad, what is the name of this? Quad R, right? And you're going to say with a center of rotation, ROTATION, of -4, 2 in an anti-clockwise direction, right? Because it's an anti-clockwise direction, right? Of 90 degrees. Alright, and that is how you would describe the single transformation that P under P that maps quadrilateral P to quadrilateral R. And that is how you would do January 2023 and all the ways to do it. Alright.